In this example problem, we have a hypothesis test for a slightly different scenario. In this case, we are going to be comparing two independent random samples that we have to figure out if there's a difference between one or the other. In this case, we are an advertising company, and we want to determine if the time of day an advertisement is run will influence the number of website searches for our product. We can advertise during the day, we can advertise during night. Is advertising during one of these two times more inducive of us getting a greater number of website hits to look at our product? Well, half these advertisements were run during the daytime hours, half of them were run during the evening, and in this data file we have the number of hits that we had in a 1 hour period after each advertisement was run. We're going to perform a hypothesis test at the 5% level, giving ourselves a 5% chance of a type 1 error to determine whether there is some kind of true difference between the two. So our null hypothesis is that the average of the first variable and the average of the second variable is the same, that there's no difference. There would be any difference in the number of hits we receive whether we ran this at night or during the day. The alternate hypothesis that we can have in this case is that one or the other leads to us having more hits than running at the other time. So running ads during the day would be more successful than during the evening, or vice versa. To do this, the best way to go about it is, you'll notice I don't have a whole bunch of stuff set up in here for numbers to be calculated, etc., because the best way to go about this is to actually use the data analysis tool pack in Excel. For the data analysis tool pack in Excel, you'll find it under the data tab, way over to the right with data analysis. If you don't have it installed already, you have to do so by going to File, down to Options. You want to go to Add-ins. You want to grab the analysis tool pack in Excel add-ins down here where it says Manage. Click Go. And you want to make sure that you have the analysis tool pack checked and hit OK, and it'll install it on your computer, and you should be able to find the data analysis button over here on the very right side of your data tab on the top. So I'm going to click on that, and I've got a whole bunch of returns in here that we could use for some kind of a statistical analysis, but we are going to do a t-test down here for a 2-sample setup. We have 2 independent samples. There are 2 different options that you have. You have the assumption that there are equal variances, that the amount of dispersion between the 2 different samples that you have is going to be relatively the same, or that there's unequal variances, that one of the 2 samples is more likely to have a much greater level of dispersion than its counterpart. For this question, we are going to assume that there is an equal variance between these 2 variables. So I want t-test 2-sample assuming equal variances, and I'm going to hit OK. When I do, it's going to ask me for a bunch of inputs that are already filled in, but I'm going to delete them out. Okay. Just give me 1 sec. There we go. Get these guys out of here. What are the things that we need? Well, the first variable range is going to be all the stuff that's in the daytime. So I'm going to actually start by clicking on the header up here for day, and then Control Shift. Oh, I'm in the wrong spot. I don't want to be in output range. I want to be in variable 1. Sorry about that. There we go. Clicking day, Control Shift down, and I'm grabbing all of those numbers from cell A1 to A31. Our second variable is the returns from our second independent sample. That was the number of website hits we had from running evening advertisements. So I'm going to click on B1, Control Shift down, grab all of those. So your ranges are just the range of information that you have for your 2 different independent samples that you have. What is the hypothesized mean difference between these 2? Well, our null hypothesis that the mean difference was going to be 0. Labels is, did you include a header someplace in your information or not? And I did. I started on cell A1 and B1, as you can see from my ranges. So I got to click the labels tab. I could have started with A2 and B2 and then highlighted all the way down and not use labels. Choice is yours. And then alpha, lastly, is the level of significance that you're going to use, the chance that you're going to allow yourself that a type 1 error is going to be made based upon your determination. Ours is 5%, so I'm going to type in 0.05. And then at the bottom, I get to choose where I want to output information here. And you have the option of putting it in a different worksheet, or you can put it in the existing worksheet. And if you want it in the existing worksheet, just like I'm going to do right now, I'm going to click in the output range box, and I'm just going to choose where I want to put it. And right here, putting it in cell D17 sounds pretty good to me. And I'm going to hit OK, and I'm going to get all of these returns over here. I want to be able to expand this so I can see what the hell it's talking about in column D. So I'm going to click on the spot between D and E, and I'm going to double click to expand it to the size that I need. So what's going on here? What does this information all mean? Well, we have our t-stat. We calculated that manually on previous hypothesis tests. It's just figured it out for us. We have a ridiculously low t. And then we have our p's, our probabilities right here. And our probability for a one-tail test and for a two-tail test. Well, what's our probability for that we're going to need for this one? It's going to be a two-tail test because my alternate hypothesis is a not equal to. If it was less than or greater than, I would use the probability of a one-tail test. And this is the p that we have in this case. And it looks weird because it is an infinitely small number. That is scientific notation. So what does this mean? It means that we got to move our decimal place 9 spots to the left because it's a negative number. 9 moves to the left means that if we had this in a different kind of decimal form over here, it would come out to point with 8 zeros after it, 1 1. It's a ridiculously super small number. Well, what does that mean? That means that the chance in this case that we say that there is a definite difference in the success of our advertising campaign between daytime advertisements and evening advertisements, the chance that we make that claim and that we end up making a type 1 error, that it actually ends up being exactly the same once we have more than just these 35 samples, that chance is so small. It is like 1/10,000,000th of a percent. Well, we're giving ourselves a 5% chance of making a type 1 error. 1/10,000,000th of a percent is definitely much smaller than 5%. So our p is way less than our alpha. And when p is less than alpha, you reject the null hypothesis in favor of the alternate hypothesis. And this one is as cut and dry as it gets. If I'm working at this advertising business and somebody makes the claim to me that it doesn't matter what time of day we run it, we can run a day versus evening, it doesn't much matter. We're going to get about the same number of hits. Just to have absolutely inclusive evidence here that it, just from the sample of 35, that there's no way that that's true. Just looking at the list of numbers we have right here, the ones in the evening column are consistently higher. Without question, we are getting much more success generating website hits for our product if we run advertisements in the evening than we do during the day. There is a non-zero difference in the true population average that we will experience for all of daytime advertisements and all evening advertisements. That we did this for 1,000 years. There is definitely a non-zero difference between those two.